Thank you for having me. I'm Ilya Klyuchnikov from Meta, and today I will be talking about eqWAlizer, between the lines about scaling Erlang development at WhatsApp with static typing. This is the logo of eqWAlizer we got very recently this week. So eqWAlizer is a type checker for Erlang as is. It was open sourced recently, and you can find it on GitHub. It was open sourced in August, 1 month ago. And the simplest analogy is that Erlang with eqWAlizer is similar to Python with MyPy or PyWrite. The very high-level story is that we started development of eqWAlizer internally in January 2021, and today the vast majority of WhatsApp code base is typed with eqWAlizer in gradual mode. And I will be talking about gradual mode and strict modes a little bit later. And we open sourced it in August this year. So this talk, let me try to tell the story of eqWAlizer from very different points of view. I will give very high-level overview of the internals and the features. My particular interest is that I would like to dive into the choices we made about designing the practical type checker. Our goal was to design a practical type checker which would work for WhatsApp in the first place. And then I have plenty of time to tell about the lessons learned, and I have slides to run some rants in the end. Okay, so I'm part of WhatsApp development infrastructure, and some of my team members, colleagues, they're already here. And in WhatsApp development infrastructure, we are responsible for many different and interesting things. It's CI, editors and editor integration, build systems, other integrations like static analysis, dynamic analysis for different needs. And in a sense, our mission inside WhatsApp is to make WhatsApp Erlang developers happy. What does it mean? First of all, to make them more productive, to make them more efficient at their work, and also to spend less time on doing some boring and boilerplate things. And inside Meta, we have quite interesting bottom-up engineering culture. What it means, primarily it means that the engineers, they have a lot of autonomy, freedom, credit and trust to start things they like, they are passionate about, and things that would bring value and impact in the future for the work, for the company. It doesn't mean that you wouldn't be accountable for, so it also means that, I will talk about it later, that things are also accountable and you have to plan them accordingly. So in spirit of this bottom engineering culture, in January 2021, we proposed this static type checker for Erlang, and you can see one of the paragraphs of this proposal, which we called the Kickoff Document. Our goal was to ship simple, fast, intuitive, sound, and user-friendly typing of Erlang as is, which would work at WhatsApp scale, making working with Erlang code in WhatsApp code base easy and more productive. And the approach is co-designing and later co-evolving the type system and code base, similar to other projects we already had in Facebook, Hack, Flow, Paya. And the type checker is being designed to require little to no effort for its adoption. The question is why? We saw that development, especially Erlang development, may be scaled through static typing. And we already saw evidences of how this may go. So inside Facebook, we migrated year by year from untyped PHP to Hack, which is a typed version of PHP. And right now it can be seen as a very separate language. The same story was about JavaScript and Flow. It's a typo. Python, Paya, and other big companies also went this route, JavaScript, TypeScript. In Microsoft, if you play some games, you may know about Lua and Luau in Roblox. Roblox open sourced Luau, the typed version of Lua this year. You may know about Ruby and Sorbet in Stripe. And there are other different projects like this. So what are the reasons to start applying static type checking to dynamically typed languages in the first place? I can tell the story of WhatsApp. You may know that in the beginning, WhatsApp had quite a small engineering team consisting of a group of very, very strong Erlang engineers. And later, for different business reasons, inside Facebook, the team started growing a lot. And when you have a small team and when you have a dynamically typed programming language, usually you have your coding conventions and your style written between the lines. You don't use much of formalism, but the problem arises when you start scaling. So when you bring more people, and especially new people, it's hard to promote this unwritten style to a bigger group of people. And this is the explanation of why the story of Hack and other type checkers happened. Would it work? I would say you never know until you try. In our case, it worked, I would say, really well. And this is a little bit more zooming into the timeline of what happened. And I will be following some details, especially technical details of how it happened. So in January, we started the project. And in May, we have the first version of eqWAlizer available through command line interface. In September, we had some IDE integration, and some people started using it from inside IDE. In December, we had support in CI, and it was possible to start using this type checker inside CI, making sure that your typed modules are not broken later. In January, we started working very closely with a few teams, and in March, we had the first project fully equalized. So equalizer is a tool, and to equalize is a verb denoting that you improve your code, and later it's accepted by equalizer. So in March, we had the first project fully equalized end-to-end, and maybe it was a sign that the tool is practical and you can use it. And approximately the same time in March and April, we start seeing the strong signs of grassroots adoption. So Erlang programmers inside WhatsApp, they started using our tool in this grassroots manner. And in July this year, this adoption became more organized. We have now a group of eqWAlizer champions, and we have some structure of how to drive adoption and how to make more and more code, more and more of Erlang code inside WhatsApp type checked with eqWAlizer. And later in August, we open sourced the type checker. So the very first question people, especially people from Erlang community and Erlang programmers, ask, what is about eqWAlizer? This is the very first question. And only after this question is answered, people become curious about technical details. So because this is such a common and popular question, let me talk a little bit about the difference between eqWAlizer and eqWAlizer. So high-level comparison, eqWAlizer is a type checker. And as Stavros has already said, eqWAlizer isn't a type checker. It's a static analysis tool which is able to do something related to type checking, I would say, tangentially. eqWAlizer has local, the approach of eqWAlizer is local analysis. Because of this approach, it's fast and can provide signal quickly. The eqWAlizer is based on the approach of global analysis. eqWAlizer can be scaled to big projects very well, and we're happy of how it works inside WhatsApp, and WhatsApp code base is quite big. Using the eqWAlizer in big projects is challenging, and it can be very, very challenging. The analysis may be slow. For eqWAlizer, we require specs to be present and types to be present for best analysis. The eqWAlizer, on the other hand, can work completely without specs. eqWAlizer in strict mode provides certain guarantees. The eqWAlizer doesn't provide guarantees, but it can find some bugs. And in terms of user-friendliness and UI, I think that we try to provide user-friendly errors, quite user-friendly errors, and from time to time, the eqWAlizer errors, especially in big projects, they may be quite cryptic. However, eqWAlizer and the eqWAlizer are complementary and can be used together, and inside WhatsApp we use both eqWAlizer and the eqWAlizer together, especially in CI. And this was one of the constraints we put into development of eqWAlizer, that eqWAlizer and the eqWAlizer shouldn't fight and shouldn't confuse our users. And there is some difference in high-level goals. For eqWAlizer, the main goal is to scale development in large code bases through typing, and for the eqWAlizer, the main goal can be seen as to catch bugs, to provide some signal about your code and about your code base. So as part of the story of eqWAlizer, WhatsApp started using the eqWAlizer a few years ago. And when you start using the eqWAlizer, especially in big projects, people started writing specs, types, then they started writing more specs and more types. And specs and types can be seen as a form of documentation, maybe the easiest and the simplest form of documentation, and especially for programmers, for engineers, it may be much easier to have documentation in the form of types rather than in terms of sentences. When you use Erlang and the eqWAlizer, such documentation may get incorrect very quickly. And bad or loose documentation may carry very little information, and sometimes it may create a huge cognitive overload when you need to think whether the documentation you're looking at, whether it's correct or not. And the quality of specs and documentation may affect productivity quite much. So let me remind you that how types and specs were introduced in the Erlang programming language. It happened in 2007. It was EP8, which was proposed by the authors of the eqWAlizer. Yeah, you can see that the rationale was that types can be used primarily to document your code function interfaces, and it can be used and exploited by tools like the eqWAlizer and edoc. And Erlang was one of the first among other dynamic languages following this path. To the best of my knowledge, probably the first one was Common Lisp in the 80s, and Common Lisp had and still has the syntax to describe some kind of types for arguments and for the results. Then 1 year before Erlang, it was Python with this proposal. Then we got Erlang, PHP, Ruby, JavaScript, TypeScript. So it's quite a common pattern across many originally dynamic languages. So just a very quick example to compare the eqWAlizer and eqWAlizer. So a very simple module, and this is a function foo, which takes, according to the spec, two values, a boolean and an atom, and it promises to return an item. And in the first clause, if the first parameter is true, it says, let me return 0, and otherwise I will return the second argument. So if you run the equalizer with default settings on this example, it produces nothing. However, you can also run the equalizer with some command line flags to try to inspect some discrepancies between your code and specs. And how the equalizer works, it has a notion of success typing, which is not very close to traditional typing. And in this case, the equalizer just says that your type specification is wrong, and the type specification for this function from the point of view of the equalizer should be this one, from any to any. Whether it's useful for the programmer, you may decide for yourself. This is the output of for the same example by eqWAlizer. eqWAlizer says that there is a type error here, and it says that we expect here an atom, and we got a number. Yeah, so here we can probably skip this. Let me speak about choices we made, and this is my favorite part of this talk. So to scale development with Erlang inside WhatsApp, the technical goal of equWAlizer was to make sure that code and specs, basically documentation, do not diverge. And more technically, equWAlizer raises an error if code goes against the spec. So the input for equWAlizer for type checking, the input specs that you have in your Erlang modules. And it also has strict and gradual mode. In gradual mode, we have some special types. We have escape hatches. We have fewer guarantees. But gradual mode allows us to adopt or to migrate existing code to equWAlizer module by module, step by step, gradually. But we also have strict mode, and in strict mode, equWAlizer provides strong guarantees, but it also more restrictive and conservative. We tried to be able to develop our type checker in incremental, or we might say in gradual way. So let me talk about how we did it. The type checker can be seen as consisted of many parts, and these are the logical parts of equWAlizer that we have as of today. We have type narrowing, we have language of types, we have occurrence typing, and many other interesting pieces. But not all the pieces came here together, and in March last year, we had only these pieces. Then we get more pieces, more pieces, more pieces. And now we also have some more improvements, basically type asserts, some fusion of dynamic types, and support for more Erlangisms. So when we were developing equWAlizer, we tried to keep the internals of equWAlizer small and orthogonal. And we tried to use existing Erlang code base as a means of validation of how good or how bad our type checker is, and also as an input for making the decisions. And we tried to structure, prioritize, and account for what we're doing. So let me try to describe the structure of equWAlizer from the point of view of code, how it's written, and you can find this on GitHub. As you may see, it's written not in Erlang, it's written in Scala. So this is what we had inside equWAlizer at the very, very first initial stage of development. equWAlizer is quite a traditional, for now, type checker. It uses local type inference. It's based on local type inference. More technically, is based on bidirectional local type inference. So it has the check mode, it has elaboration mode or inference mode, and then you can see there are some Erlang specifics or Erlang specialities. There is elaboration of guards, elaboration of patterns, and there is narrowing of types. Later, we got more features. We got generics. This is primarily in this module. Then we got elaboration of some custom functions, and this was for practical reasons. You may know that there are some modules like lists and maps in standard OTP library, which have some very, very oftenly used functions, and these functions may be hard to be, well, the applications of these functions may have quite tricky semantics if you try to be very, very precise about type checking. So we put some knowledge about these functions and how to type check them directly into the type checker. Then there is this part to work with overloaded specs and these behaviors and these callbacks. And later, we added support for occurrence typing. I will talk a little bit about it. And we added support for rich recursive types. And the main most interesting thing is contractivity checks. And then we added support for gradual typing. Gradual typing is implemented through special type equalizer dynamic. And also we have escape hatches. If you have a type error inside your code base, and if you use equalizer in gradual mode, you can suppress the type errors via escape hatches. Just put these magic comments one line above the type error, and it will be okay. And we also have error tolerance when we try to display as many type errors as you have in your modules, not just the first type error that you have. Yeah, and also we have proper support of occurrence typing, gradual typing. However, making decisions for supporting or not supporting the particular features. If you go on GitHub into code base of eqWAlizer, you may see that there is a package called analysis, and we have more than 30 different lightweight analysis. For one of the examples, you may know that in Erlang, you may have already bound variable